Reaching carbon neutrality has become an ever more pressing worldwide challenge. HeidelbergCement is playing its part by investing in groundbreaking technologies to reduce CO2 emissions. Moreover, it's doing so at all stages of the cement and concrete production process and also through recycling concrete. In a previous animation, we discussed 3 technologies that capture unavoidable CO2 emissions, which are released when limestone is converted into clinker, a process called calcination. We'll focus now on the last part of the cement production, when hot clinker, the main ingredient of cement, emerges from the kiln, is cooled and then finely ground to become cement. Innovative thinking and new approaches may also bring about sustainable solutions here. A range of what are called supplementary cementitious materials can be added to reduce the amount of clinker in cement and thereby reduce the CO2 footprint. These materials can be the byproducts from other industries which would otherwise go to waste. Tweaking the recipes for cement is one way to reduce its carbon footprint, to conserve natural resources, as well as to increase the strength and durability of concrete. The cement is transported to ready-mix concrete companies, where it will be processed into concrete, which can then be used in a variety of construction projects, such as buildings or infrastructure. As soon as it's poured, concrete becomes a CO2 sponge. The calcium oxide in the concrete absorbs CO2 when in contact with air. This is due to a natural chemical reaction called recarbonation. The calcium oxide is hungry for the CO2 that it lost during the calcination process already mentioned. An average 20% of the CO2 emitted during the calcination process will be naturally reabsorbed during the lifetime of various concrete products or structures that are exposed to air. However, even the remaining non-carbonated 80% of the calcium oxide can be utilised to reduce CO2 emissions. Learning from the natural chemical reactions, HeidelbergCement developed industrial technologies to give new life to used concrete through a CO2 negative process. There is a huge opportunity in recycling demolished concrete. New recycling technologies allow selective crushing and low-pressure grinding for efficient separation of the demolished concrete. In the recycling plant, the demolished concrete gets separated into sand, aggregates such as gravel, and what is called recycled concrete paste, or RCP. High-quality recycled sand and aggregates can replace up to 100% of their respective virgin materials in the concrete mix, without increasing the cement content or admixture dosage, and without impacting the workability or strength. The recycled concrete paste can be used in 2 ways. On the one hand, it can be directly utilised and replace part of the limestone in the raw meal for clinker production. Compared to the virgin material limestone, the calcium oxide in the RCP is 80% CO2 free. In this way, the use of the recycled paste as a limestone substitute not only reduces the need for virgin materials, but it provides low CO2 clinker. On the other hand, the recycled concrete paste, due to its remaining carbonation potential, can be used for a CO2 sequestration technology called enforced carbonation. The carbon dioxide, which is released by the clinker production process, is redirected and cooled down. In the absorber, the RCP gets continuously exposed to the flue gas stream. The CO2 reacts with the calcium oxide present in the RCP and forms calcite, the main mineral found in limestone. The silica and alumina, also present in the RCP, form a pozzolanic, highly reactive gel. This recarbonated, recycled concrete paste can be utilised as clinker replacement and can also replace the supplementary cementitious materials. The result? Cements with an even lower CO2 footprint. On its path to carbon neutrality, HeidelbergCement not only supports the circular economy through efficient use of resources and co-processing waste material, but also through recycling concrete.